Delegation is a software design pattern where a class will pass on the responsibility of carrying out certain tasks to another class. Imagine a manager dishing out tasks to his team members based on their skills in order to achieve a common goal. When a class, which is usually called the delegator, receives a request, and that request in this instance is a task, that class that received the original request, which is the delegator, remember we said that the class that takes the original request is the delegator, okay? And this instance, the request is just a task. So the delegator can forward that task to another class, which is known as the delegate, okay? It is the delegator that will receive the original request, and the delegator is going to forward that request to the delegate, and the delegate is another class that is going to process the request, okay? All this is done while ensuring that the delegator still maintains the context of the original task. That is to say that the delegate cannot have access to process the request without immediate permission from the delegator, okay? Because the delegator is maintaining the context of the original request. If we made that request with an argument, the delegator is still going to have access to the arguments we passed to the delegates to process that request, okay? The delegate design pattern, which we will consider in this video, provides a structured way to implement delegation explicitly, ensuring that we make sense of everything in our code base and we can easily update or change the code. In today's video, we will look at the following talking points. We are going to look at the concept of delegation. We are going to look at some code examples. We are going to look at the benefits and the drawbacks of implementing delegation. Last but not the least, then we are going to look at some strategies to implement delegation. Let's look at the concept of delegation, okay? Let me bring in an analogy that helps you to make sense of what delegation is. So imagine a restaurant where a customer is going to ask for a specific dish. The process of that customer asking for that specific dish is then making a request, okay? Now, when that customer has asked for the specific dish or when they have made their request, obviously they have to make that request or ask for that specific dish from a waiter. The waiter is going to be the delegator in this instance because it is the waiter that is taking the customer's request, okay, which is the original request. The waiter is going to take that request, but the waiter cannot process that request by themselves because that restaurant is going to have a cook whose responsibility is cooking meals, okay? So the waiter, being the delegator, is going to take that request that the customer has made and is going to pass it on to the chef. And the chef now becomes the delegate in this instance because the chef is going to receive the customer's order from the waiter. You are seeing that the waiter is still maintaining the context of the original request. The chef, being the delegate here, just takes the request from the waiter, processes it, and then returns a dish back to the waiter. The waiter is going to take the dish that has been prepared by the chef and give it back to the customer, okay? In this instance, the waiter has fulfilled the request, okay, by delivering the dish to the customer. But the waiter did not make that dish themselves, okay? The waiter just took the customer's order, which is the request, and passed that request on to the chef, which is the delegate, okay? So that is the way delegation works. Let's look at a code example of delegation and how we can implement it in our classes. So I'm going to go ahead and create an interface. And this interface is going to be a printer interface. This printer interface is going to have one method defined on it, a print method. This method is going to accept a text, which is going to be a string, and it's just going to return a boolean, right? Okay, this is an interface definition. I'm also going to define another interface. This interface is going to be a scanner, and this interface is also going to have one method defined on it, scan. This scan is going to take in a document, which is going to be of type any, and let me just put, it's going to return a string. Now we have defined these two interfaces. I'm going to define another interface. Let me make my editor much larger so you see my text more clearly. I'm going to define a class, ink printer, and this ink printer is going to implement the printer interface. Then this needs to define the print method, okay? So what we are going to do is just say print, remove this, and this is going to return true. Then I'm going to create a new class, not caches class, and this class is going to be a color scanner, and this is going to implement the scanner interface, okay? This is going to have one method defined on it, and this is going to be scan. This is just going to return a string, So I'm going to say return document card console. Now we are done with that. The next thing I'm going to do is to define a new class, okay? This class is going to be known as, first of all, we have an error here. I didn't put color, close that up. So let me go ahead and define that new class. It's going to be class device. And this is going to implement the printer and the scanner. This needs to have a print method, right? Which is going to take in a document, which is going to be of any, and it's just going to return true. Then we don't print a document, we print a text rather. Meanwhile, this is going to implement a scan method. This is going to take in a document. It's a document we scan, and this is going to be of type string. Then we're just going to return document scanned, document scanned. Now I need to do two more things. First of all, let me console log this text here. So we are using it obviously. Now I've done that. I need to define two stateful variables. I'm going to say private printer, which is going to be of type printer is equal to new printer. Then we don't have a digital printer, new printer. Oh, we can't have a new printer, it's an ink printer. Then I'm going to create another private variable. This is going to be of type scanner. It's going to be equal to new color scanner. Now I'm going to replace this with this logic we have inside this print function with this dot printer dot print, and this is going to take in that text. I'm going to return, while I'm also going to return this dot scanner dot scan document. Okay, let me console log this text here. Now that I've done that, let me go ahead and explain what all of this, okay? You can see that from the code example we have here, we have two interfaces, okay? We have an interface for a printer and an interface for a scanner, and the two of them collectively define what a printer can do and what a scanner can do, okay? And after the interface definitions, I go ahead and I define a new class here, an in-printer class that implements the printer, and this has one method defined on it, the print method that takes a text, just console log that text and then we return true. I've also defined a second class here, which is the color scanner class. This color scanner class implements a scanner. It has one method defined on it, which is the scan, and this is according to this interface of a scanner. All scanner must have a scan method, and we just console log the document which we pass in as argument to the scan method, and then we return a string that says document scanned. Now we have a new class definition under the color scanner. This class is the device, and this device implements the printer and the scanner. And we create two variables, a printer variable which is equal to a new ink printer, and a scanner variable which is equal to new color scanner, okay? Now, since this device class is implementing a printer and a scanner, it needs to have a print method defined on it, and it needs to have a scan method defined on it. So we have defined a print method here that takes in the text of type any, and instead of processing this print request ourselves, what we just do is we call this.printer.print and passing the text that was passed to this print function, while we just return the result of calling this.printer.print, okay? This matches what we said. This device is going to take in the original request, which is this print request, but however, this device is not going to process this print request. It's going to pass this print request to a printer, and we have already defined a printer on this device, which is this here. So we have to use this.printer.print, and we're passing that text. And by doing this, we are ensuring that the device is maintaining the original context of this request, okay? Because at the end of the day, this function is just returning the result of calling this.printer.print, okay? And under the print function, we have a scan method defined on it. This scan method accepts a document, which is a string, and then it just returns this.scanner.scan. We pass the document to it. We are also doing the same thing like we did in the print function, okay? The device is not responsible for printing this document. Its job is just to take in the request, which is whenever a part of our code calls this scan function and passes in the document as an argument to it. So what this device is going to do, it is going to take this document to pass in as an argument to it, and it's going to check on itself and say, oh, this scanner, come here, scan this document and return the result for me. And that is what we are doing here. It has delegated the result of scanning this document to this, okay? because by calling this.scanner.scan and passing the document that was passed as an argument to it, we are telling the scanner to process it. And then we just use the return statement to return the result of scanning the document back to the user, okay? And like I said, by doing this, storing the printer and the scanner as status variables on top of the device, we are ensuring that the device is maintaining the context of the original request. As good as delegation may be, it obviously comes with some benefits and some trade-offs, okay? Delegation is very powerful in software design. However, it is essential to be aware of potential pitfalls and for us to use delegation strategically for us to reap the rewards without incurring any unnecessary overheads, okay? You should know that the decision to use delegation should be based on the specific needs of your project and the complexities of the tasks involved. So it's not going to make sense for you to take a very simple task that can be managed by a class and to delegate it to another class entirely, creating a whole new level of complexities. Let's look at the benefits of implementing delegation, okay? Obviously, delegation breaks down complex functionalities into smaller, well-defined units, making our code easier to understand and maintain, okay? Because at the ending of the day, from what we have here, an ink printer is just responsible for printing a document, and a color scanner is just responsible for scanning a document. Each object is focusing on its specific responsibilities, leading to a clearer and more concise code. Because by looking at this, we know that it's only the printer that can print. We know that only the scanner that can scan. And even if this device has a print and a scan method on it, it is not actually printing or scanning. It's just forwarding it to the printer or the scanner. And by delegating tasks to specialized objects, you can easily swap or modify them without affecting the core logic of all of your code, okay? This makes your software adaptable to changing requirements and easier to extend with new features, okay? By ensuring that each of our classes are responsible for only one thing, we can come over here, and if I want to do something else with this text, I can just say do something else with text. And that is not going to affect any of the implementation we have here, because everything here is still going to be working fine, okay? This is because of the modularity of our code. We can also come here, add extra methods on this color scanner as may be needed by this class, okay? And that is still not going to affect this device, okay? That's one of the benefits of delegating tasks, okay? However, we choose to process the tasks we have delegated inside of the delegate is none of the business of the delegator. The job of the delegator is just to take the task and delegate it to the delegate. The delegate processes it and returns the request. So if we change how the delegate is processing the request, it is not going to affect the device, okay? Because as long as there isn't an error, the device is still just going to take the result of processing the request and returning it back to the client, okay? So another advantage of delegation is that it also allows us to modify specific functionalities in our code without impacting the entire system. This reduces the risk of cascading errors and makes the debugging process a bit more smoother. Another advantage of using delegation is that delegate objects can be shared across different parts of the system, reducing code duplication and improving efficiency. Now let's look at the drawbacks of implementing delegation. Creating and managing delegate objects can introduce additional complexities, especially for small or simple tasks. It is a no-brainer for very small tasks. The trade-off between modularity and overhead needs to be considered when implementing delegation. And like I said, it's not going to make sense for us to take a very simple request that can be processed by a class and delegate it to another class, creating a chain of classes that is going to be very, very difficult for us to maintain in the future, because that task can be processed by the delegator. There's no need for us to take that task and then push it onto another class. It is a very simple task, okay? So when it comes to delegating a task to another class, it has to be something complex. Another drawback of using delegation is that it adds another layer of indirection through delegation, and that can slightly impact performance of your application, okay? Make sure that you evaluate the potential performance bottlenecks involved when using delegation for performance critical tasks. Misusing delegation can also introduce implicit dependencies between objects, making the code less modular and more difficult to test. Ensure there is a clear separation of responsibility and loose coupling between your objects when you are implementing delegation. And while isolating issues within individual objects can help debugging, tracing problems across several delegated tasks can be more challenging. Utilize clear logging and error handling mechanism when employing delegation. Now let's look at some implementation strategies when working with delegation. We can use the delegate design pattern, and this delegate design pattern is what we've considered in the example in this video. You can also use the strategy pattern, and strategy pattern involves switching between different algorithms for the same task at runtime. This promotes flexibility and adaptability because it allows you to define and switch between different algorithms or behaviors for your classes and provides a common interface for interchangeable implementation of those operations. Okay. You can also use the observer pattern to implement delegation, and the observer pattern leverages delegation to notify interested objects about state changes in our application. Okay. Objects, which are the observers, are going to register their interest in another object, which is the subject, and they are automatically notified whenever the subject's state has changed. This pattern also avoids tight coupling with specific values or events and enables multiple objects to react to changes in a single source. So that's going to be it for this video, guys. I hope you found this video interesting and you liked it. Please leave it a like, subscribe to the channel so you can get access to all our videos in the future as a drop, and I'm going to see you in the next one.